Oh, Algebra 2. We're going to try this video again. Hopefully this time it comes out steadier. It doesn't make you all seasick. We're going to start with our notes on a page that says Example 4 at the top. We will go over Assignment 2 when I get back. We will also go over Assignment 3. Assignment 3 is going to cover what we're doing today in these notes. Okay, what we're doing today in the notes is not going to be as hard as what Assignment 2 seemed like. It's going to be the same thing where it's asking you basically to find the vertex, but now because the equations aren't going to be in standard form, it'll be a little bit easier. Okay. While you're watching this at any point, go ahead and pause it so y'all can catch up and write things down or whatever, because I'm just going to go right through it. Remember, it is also posted on Classroom where you're finding it, so that means you can go back and watch it at any time. Okay, so example 4. The path of a place-kicked football can be modeled by blah, 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 where x is the horizontal distance in yards and the y is the corresponding height in yards. A, how far is the football kicked? B, what is the football's maximum height? And there are the magic words, maximum height. That means you're looking for the vertex. So all we have to do is identify what form this equation is, and then if you ever forget, your yellow paper tells you how to find the vertex. Okay, so this equation is not standard form because you don't see an x squared and an x. You're going to be tempted to say that it's vertex form because it has the one set of parentheses, but it doesn't have a squared on the outside of the parentheses. So this is actually intercept form in disguise. If we write it the way you're used to looking at it, it's going to look like this. Negative 0.026x plus 0 times x minus 46. So this clearly tells you the P and the Q. Remember, P and Q are our x-intercepts. And when you're talking about kicking a football, the ground is acting like your x-intercept. So when you're thinking of where does this football intercept the ground, you're thinking at the beginning when it's on the ground before they've kicked it, and later when it hits the ground after they've kicked it. So these two are telling us how far the football goes. It's starting at 0, it's landing at 46, so it has gone 46 yards. Super easy, right? Now, what is the football's maximum height? Here we're finding the vertex. That means we need to know where the axis of symmetry is. Remember, the axis of symmetry is halfway in between the two intercepts. So it's going to be halfway between 0 and 46. Something just landed on me. A bug. Okay. So our axis of symmetry is at 23. We want that because now we're going to take the 23, plug it back into the original equation. We do this math. So what you're doing is you're multiplying these two things. You're subtracting these two, and then you're multiplying the two answers that you get. So this tells you that the football went 13.75 yards in the air. Now, example 5 is very similar. What is the maximum height of the football if the football's path can be modeled by blah, 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 blah? It's a different equation. Okay, so we're going to start the same way. This time they don't care how far it went, but we still need to find the middle. So our two intercepts are 0 and 50. Halfway between them is 25. Take the 25, plug it back into the equation. Remember, again, you're multiplying these two, subtracting these two, and then multiplying the two answers. And since they're both negative, we'll end up with a positive answer. So the football went 15.63 yards in the air. Okay, example 6 now. The Tacoma Narrows Bridge in Washington has two towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by the function blah, 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 where x and y are measured in feet. What is the distance d between the two towers? So with our little drawing here, they want us to find d. Okay, this equation is vertex form. Vertex form tells you the vertex. If you know the vertex, boy, you're going to be able to answer this super fast. Easy. Okay, so what does our vertex tell us? Remember, it's going to be h and k, opposite sign of h. So our vertex is 1400, 27. The 27 is telling you how far the cable is above the roadway. So it's telling you where this vertex is. So the cable is only 27 feet above the roadway. Now the 1400 gets you halfway in between. So all we have to do is W the 1400 to find out how far the towers are. That's the hardest math you're going to have to do. Find the H, multiply by 2. Okay, example 7. Suppose an architect designs a bridge with cables that can be modeled by blah, 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 where X and Y are measured in feet. Compare this function's graph to the graph of the function in example 6. Now, this is also vertex form, and its vertex is also 1400, 27. So the vertexes are the same. The only thing that's different is the A. Okay, this is the equation from example 6. This is the equation from example 7. Now you have to figure out, what does A tell you about the graph? It tells you whether it opens up or down. These are both positive, so they're both opening up. And remember, A also tells you whether it gets wider or thinner. Okay, the A on this one is a bigger number. If you get 1 out of 6,500 parts, you're going to get a bigger piece than if you get 1 out of 7,000 parts. Okay, think about, I don't know, a cake. You cut that cake into 6,500 pieces, or you cut it into 7,000 pieces, you get a slightly bigger piece of cake on this one. Okay, so since our A is bigger, that means our parabola is going to be thinner. So that means the cables on this one are steeper. That's it. Now, next, I'm going to have you click on a video that is actually of the Tacoma Narrows Bridge in Washington. It is a real bridge. I'll tell you a little bit more about that once we get to the video part. And then I want you to do, whoops, it went the wrong way. I want you to do assignment 3, page 16 through 17, 51 through 58, A and B. I think there's a C on page part 55, so just do A and B. And then number 56. And I will see you over at the video.